All right, hello. I'm going to be solving a couple of problems here using Polyus problem solving methodology and the 4 phases that go along with that. I'd like to highlight what my group had defined as a problem, which we said is a situation requiring a solution or path of resolution involving struggle. I've also additionally added in the definition that we had for mathematics as well as problem solving, just to kind of see where everyone else was at on that as well. So I'm going to talk a little bit about the 4 stages of Polyus problem solving and then get into these 2 problems. So the problem solving methodology that Polyus has developed in phase 1 was to understand the problem, seeing clearly what is required. It makes sense that this would be the first step or the first phase, as many times we just try to skip to the details and get started, but it's a good spot to start here with understanding the problem fully. Phase 2 is to see the connectiveness and to kind of put the items or variables, whatever might be involved in the problem, together to see how they link and then go ahead and make a plan. Phase 3, again, to carry out that plan described in the previous phase, and then phase 4 is to look back and ensure that the solution makes sense in the context of the problem. So the reason I chose 2 problems today is one of them is very directly algebraically based, and the other is definitely a little bit more outside the box and requires some critical thinking skills and some creativity. So let's go ahead and get started. Okay, let's go ahead and get started with number 1. This problem, as well as the second problem, can both be found in Poly's book, How to Solve It. And I found them very interesting and thought maybe these would be good problems to work through. Okay, so I'm going to go ahead and read it, and we'll talk through the phases and then come to a solution. To number the pages of a bulky volume, the printer used 2,989 digits. How many pages has this volume? Okay, so understanding the problem. The first thing that I did was I drew a picture. So in phase 1, I kind of started to draw a series of pages that I imagined were within this volume. Okay, so here's page 1. And then page 2, and so on. And I thought, maybe I'll go out to, page 101 and start to think about what's really going on here and what the question is asking. Okay, so as I look at these pages, I can say to myself, well, here's 1 digit, here's another page with 1 digit, and then of course I've got a bunch of pages in between, but here's another page, page 101, that has 3 digits. So it got me to thinking about how many single-digit pages there'd be, double-digit, triple-digit, and then quadruple or 4-digit pages. So within the context of phase 1, I'm just trying to understand, what's the connectiveness, and I'm kind of skipping to phase 2 in the process, but what's the connectiveness between the number of digits on a given page and the total number of digits used on all pages. So it got me to this. It got me to a place, of course, phase 1 here, I'll put this in red. I need to know the number of single, double, triple, and quadruple or 4-digit pages that exist. Digit pages that exist. That's my goal. At least that's my first goal. Then my second goal is to figure out how many pages would be required then to accumulate 2,989 digits. Okay, so that's phase 1. Phase 2, put this in blue. Phase 2, the connectedness. Okay, so I started to think about this then. I said, okay, well, let's call the single digit page the number of single-digit pages, S. Each single-digit page is going to be worth 1 digit, right? Each double-digit page is going to be worth 2. So S would be the number of single-digit pages. D would be the number of double-digit pages, and so on and so forth. I'm going to make a very fair assumption. Actually, it's probably not a fair assumption, but I'm going to make an assumption right off the bat that I'm only going to need up to a 4-digit page in order to accumulate 2,989 digits. Okay, that might be an unfair assumption, but I would figure it out relatively quickly as I get into the math. Okay, so I've got 1s plus 2d plus 3t plus 4q, and what I want that to equal is 2,989. Okay, so now I'm going to carry out my plan. I'm going to carry it out in green here, and then we'll look back to finish it up. Okay, so as I carry out my plan, I think about single-digit pages. Well, there is no page 0. Let's make the assumption that we start on page 1. So pages 1 through 9 would all have single digits. This would equate to 9 total pages, which will equal S. Okay, then we have the pages 10 through 99, which tells us then that there are 90 double-digit pages. Okay, the triple-digit pages would be those labeled 100, which is the next available page, up to 999, which implies that T equals 900. And finally, at least as far as I'm going to go for this video, and this is all I'll need, is I'm going to go from 1,000 up to 9,999. It's the largest 4-digit number that exists, integer value at least. And that's going to tell us then that Q is equal to 9,000. Okay, so I'm going to work my plan here a little bit. My plan is to figure out if S is equal to 9. I'm going to use my equation written in blue above here. I'm going to take 1 times 9 plus 2 times 90. Right? If I have 90 double-digit pages, then there would be 2 digits per page, making 180 digits for those 90 pages. Accumulate those. I'm going to take 900 times 3. And actually, I'm going to cut it off right there. And the reason I cut it off right there, and I didn't need a quadruple page at all, I'm not going to use Q, is because if I add that up, I'm going to get 2,889, which puts me really, really close to my goal of 2,989. Okay, so in 900 pages, what does this imply? That in 900 pages starts with a P, by the way. There we go. There exist, I think this is the symbol for there exist, 2,889 digits, at least for labeling the page numbers. There could be digits within the text, but we're not counting those. Okay, so when I look back, if I were to take 2,989 and I were to subtract 2,889, I'm left with 100 digits. I'm left with 100 digits. So, interesting. Now I just caught myself. I had made a mistake. This happens. Maybe, yeah, I'll go ahead and no, you know what? I'm gonna wait till phase 4. That'll make phase 4 a little more impactful. Okay, so let's continue as if I didn't realize I made a mistake. Okay, that leaves 100 additional digits left. Well, now that I have exhausted all single digit, double digit, and triple digit pages, I have to work my way into the quadruple digit pages. So if each page has 4 digits on it, then I would take 100 and divide by 4, giving me the total number of additional pages. Okay, so at this point, I could say that if I took the 900 pages, this is where my mistake will come in, and then the additional 25 pages, that this volume would have 925 pages. Okay, so let's go on to phase 4, and kind of look at the issues that have arisen. Okay, so phase 4. Does this make sense? Well, as I look back, I like my strategy. I believe I understand the problem thoroughly. The connectiveness I like. It's the carrying out the plan that I have a problem with. Okay, so let's go back and examine this and then figure out where the mistake was. Okay, so I have 9 single-digit pages. That's pages 1 through 9. I have 90 double-digit pages. That's from page 10 up to 99. I have 900 triple-digit pages. That's from 100 to 999. I made the mistake of thinking that there were 900 pages accumulated to this point. This is a mistake. So if I were to add up 9 times 1 and 90 times 2 and 900 times 3, I do get 2889, but that's not in the first 900 pages. That's in the first 999 pages. Okay, so my mistake would be then compounded here, which makes this answer incorrect. So what I would get is 1,024 total pages in this volume. All right, that's it for this problem. I'm going to move on to the second problem that I have here, and it's much different. It's a little bit more of a thinker and tinker as I like to think about it. I got to play with it a little bit more. It's not quite so explicitly defined. It's a little bit more abstract. So let's go ahead and jump into that example. Okay, a bear starting from the point P walked 1 mile due south, changed direction, walked 1 mile due east. He turned again to the left and walked 1 mile due north and arrived exactly at the point P where he had started from. What was the color of the bear? Okay, so initial thoughts. There's something weird going on here, right? Because as I think about this, just in a geometric sense, let's say this is point P, and the bear walks south 1 mile, makes a left turn. Okay, we make the assumption that's a right angle, walks 1 mile, turns left, walks 1 mile. We got a problem here, right? Okay, so that makes me think that there's something funky going on here, at least from a two-dimensional geometric standpoint. The other thing that kind of catches my attention is just kind of how random the question at the end is here. What color is the bear? So that gets me thinking, makes me think, okay, well, what kind of bears are there? Okay, are there any tricks going on here? Which there isn't actually, but initially it makes you think, okay, is this a black bear? Is it a brown bear? Is it a grizzly bear? Is it a panda bear? All sorts of different questions. So you have to kind of think outside the box, but I think I understand the problem. There's going to be some kind of connection, and I'm gonna kind of star phase 1 and put, is there a connection to geography? would that geography help me to determine, bear species that might live in that area? Species, let's spell, there we go. Okay, connectiveness. All right, as mathematicians, we many times live, in 2 dimensions. I mean, we go into 3 dimensions as well, but, this idea of north and south and east and west kind of puts you many times onto, a map that might be laying on a flat surface. But in reality, the map is actually on a curved surface, right? So as we think about, north and south, east and west, we actually have these kind of skewed ideas about what that really means. So north and south run along these, I think those are the latitudes, right? Or those longitudes, I can't remember. Right? But where do all of the north-south, what we want to call line segments, where do they meet up? They meet up, kind of right here at the north and of course the south poles. Okay, and then they're met, right? They're met by these horizontal lines, right? And we like to think of these as right angles. Okay, so I'm kind of living on, like, if I can imagine, right, that these are the north-south. I can't remember which one's which, so I'm going to call them longitudes. I don't remember. And these are your latitudes. Like, I can kind of imagine myself being right in here. Oops, let's do a different color. How about black? There we go. Kind of living right in that little space on the globe. Okay, so it makes me start to think, like, is this connected to, right, the northern or southern poles on the Earth? Okay, so this is kind of like the heavy lifting is done in phase 1 and 2, because I think I have an idea of what it is. I have an idea. So I'm going to carry out this plan in phase 3, and I didn't write anything down for phase 2, but my sketch is kind of my connectiveness. Okay, so I'm going to carry out this plan, and I'm going to hypothesize that the polar bear is the bear we're talking about, and here's why. All right, so I'm going to cut out my my little sketch here. I'm going to put the North Pole. And for that matter, I guess well, we'll get to that in a minute. And I'm gonna put this on the, like, kind of enlarge this a little bit. Okay, so bear starts at point P and heads south for 1 mile. Now, this curved vantage point is accurate, even though we kind of live on what we consider a flat surface in our finite space that we're able to visualize. As we head south, then we have the bear taking a left, which is again east, and heading 1 mile east. Don't judge my picture to scale. And then finally takes another left, heading due north for 1 mile. Okay, and of course would then have to end up back at the North Pole. Very interesting. So I'm gonna make a claim here that this polar bear was clean and had not been in the dirt, had just had a bath, and therefore the bear is white. Okay, so phase 4, looking back, this makes sense, right? I feel like it makes sense. Now, I also feel like it could be very easy to say, well, that must be true, and of the South Pole. Well, this scenario couldn't happen at the South Pole unless the bear started at a point P and walked 1 mile due north. Right? So if you switch out north and south in this problem, then you would have whatever kind of bear lives at the South Pole. So that's what I got. I felt like Polyus' method has had an impact on how I will teach problem solving, just to kind of give students a nice way to get from point A to point B with some structure. So that's all I got. Look forward to seeing your videos. Have a good night.